Okay, so today we are going to continue our discussion on probability. We've been talking about theoretical probability over the last couple of lessons, and that's predicting what's going to happen based on what can happen around the parameters of the particular scenario that we're talking about. Okay, so experimental probability is what we're going to switch over to today. That is referring to actual data that has already happened in an experiment, and then we're going to use that to predict what the outcome is going to be moving forward. Okay, so let's kind of compare the two, and then we'll take a look at some examples of how experimental probability works, right? So theoretical probability, we remember that when we're setting up our ratio, we're talking about favorable outcomes and we're talking about total outcomes, right? So favorable outcomes is how many ways we can get our desired result. So how many ways can the thing that we want to happen actually happen in this scenario, okay? So with an experiment, we talk about what's called trials. All right, so a trial is basically every time we conduct an experiment. It could be rolling of a dice, or pulling a card out of a deck, or a marble out of a bag, or whatever the example is. It's based on how many times something has actually happened over a set of trials. All right, so each time we do that, that's a trial. So if I roll the dice once, that's a trial. I roll it again, that's 2 trials, and so on. All right, so those trials is what determines how many times it happens during that experiment. All right, and that is known as frequency. Okay, so frequency is simply saying how many times has that desired result already happened during this experiment. Okay, all right, now, and so for theoretical, we talked about favorable outcomes, and then we divide that by total outcomes, right? So that's how many different things can actually happen, whether it's their desired result or not. It's how many total things can happen in this particular scenario, all right? With the experimental probability, all right, we divide it by total number of trials. So we say, how many times has our desired result already happened compared to the total number of trials that we did. All right, so for example, let's say I was rolling a die and I rolled it 100 times. Okay, so if I roll it 100 times, that's my total trials. That's how many times I rolled it. The frequency is how many times did my desired number come up. So let's say I wanted to know how many times did 3 come up when I rolled it. So I would simply count out of all my 100 rolls, how many times did 3 come up? That would be my frequency, and then I would use that to predict how often that 3 is going to come up in future trials. Okay, so let's take a look at an example of different ways that we can use experimental probability. Here we have our 6-sided number cube. All right, and so we're going to take a look at some hypothetical data. All right, so remember, we need data in order to make predictions using experimental probability, all right, because it's based on, again, what has already happened. All right, so let's say that we take this number cube and we roll it, all right, 100 times, and each time we roll it, we log what the result was and how many times that comes up. All right, so for this particular example, all right, our results, all right, possible results are 1, 2, 3, 4, 5, and 6 for rolling just one cube. All right, and the frequency, remember, is how many times each one of those numbers came up when we rolled it. All right, so in that particular case, a 6 came up, so I would log it under the result of 6. And as I would do it 100 times, all the frequencies should add up to 100 on how many times each number come up. Now, theoretical probability suggests that if we roll it 100 times, then each number should come up an equal number of times, right? Because they're all equally likely. But it doesn't always happen that way. If I continue to roll it 1,000 or 10,000 or 100,000 times, then those numbers would get closer together because they are equally likely. But the smaller amount of trials that we do, the less chance you have for them to come up with those numbers to be the same. The more trials that we do, the closer we'll get to the theoretical probability prediction. All right, so here's our data. All right, so we rolled it. All right, so 17 times a 1 came up, a 2 came up 22 times, a 3 came up 16 times, 4 came up 12 times, 5 came up 24 times, and 6 came up 9 times. All right, so obviously these numbers are a little bit different from each other, but again, this is just how they rolled when we conducted the experiment. So now we're going to make some predictions based on that information on what's going to happen moving forward. All right, so let's say based on this data, what's the probability if I roll this number cube that 3 is going to come up? All right, so then I'm going to say, okay, well, I'm going to first take my trials, all right, and total number of trials, that's going to be the bottom part of my ratio, so the total of 100 trials. And then I'm going to take my frequency of how many times that desired outcome has already happened in those 100 trials. So in that 100 trials, a 3 came up 16 times. So I'm going to go through and say, okay, well, that means that the probability coming up is 16 out of 100 because that's what happened in my experiment. So then I would take either simplify the fraction where I could put it in fraction form. So in this case, this would reduce to 4 over 25. Or I could put it in my calculator and just do simply 4 divided by 25 or 16 divided by 100. And that would obviously give me 0.16 or a 16% chance of a 3 coming up. Okay, so simply taking how many times has it happened, which is the frequency, divided by total number of trials in that particular experiment. Okay, so we can also do other things as well. Let's say we wanted to say what's probability an even number comes up based on this data. All right, so we need to take a look at the 3 even numbers, so 2, 4, and 6. And we want to take the frequency, which is the total number of times either of those 3 come up. All right, so anytime that I roll it, how many times did an even number come up? So I'm going to take the frequency for the 2, the 4, and the 6, and I'm going to actually add those together, and that's going to give you my total frequency. That's how many times an even number came up. 2 came up 22 times, all right, 4 came up 12 times, so that's a total of 34 there, plus another 9 for the 6s, so that's going to be 43 times. So my frequency, in this case, all right, this was probability of 3. All right, here we're going to do probability of an even number. All right, and we said that came up 43 times out of our 100 trials. All right, so in decimal form, that would be 0.43 or a 43% chance that an even number would come up. All right, so that was an example, very simple based on our 6-sided number cube. Let's take a look at some other scenarios as well. Here we have another scenario where we can use some experimental data. All right, so let's say we have a little spinner here that has 4 sections. All right, and every time we spin it, then it's got 4 possible outcomes. It could come up on the black, blue, red, or green. All right, so let's say that we spun this spinner 50 times, all right, and here were the results that we got. So it came up on black 6 times, blue 19 times, red 11, and green 14. Now, obviously, with theoretical, we would say that because the sections are all the same size, that they are equally likely to come up, and it would be a 1 in 4 chance that each one would come up. All right, but in this case, this is how the experiment played out, so we're going to use that data to predict what's going to happen if we continue spinning it. All right, so let's say, for example, we want to find the probability of it coming up blue. Okay, so probability if we spin it that it's going to land on blue. So we're going to take a look at the frequency of that. So blue happened 19 times. So that's the frequency of blue over the total. Add them all up, which was 50. All right, so then our ratio is going to be 19 over 50. All right, so in our calculator, we can simply do 19 divided by 50, and that in decimal form is 0.38, or in other words, we have a 38% chance that blue is going to come up if we spin it. Okay. We can also look at something that's similar to a complement. So let's say we want to know what's the probability if I spin it that a color comes up not red. Okay, so if I spin it, I want not red, which means that the frequency of it coming up not red is the other three added together. All right, so the 6, the 19, and the 14, the blue, black, and the green, those are all not red, obviously. So how many times did a color come up that's not red? Well, red came up 11 times, so I'm going to subtract that from the total trials, and that'll tell me that, or I can just add these three together. All right, so that means that my frequency of a color coming up that's not red is 39. Total frequency is still 50 trials, and so then I'm going to simply divide those. And in this case, I get 0.78, or there's a 78% chance if I spin it that a color will come up that's not red.